Hello, everyone. Nice to see you, so many of you here. And thank you so much for coming to this presentation. My name is Sebastian. I'm the CTO and co-founder of a company called Castle. We're an account security platform, and we're trying to help our customers to detect whether their users are basically hacked. So I'm kind of excited to be here today to talk about a often overlooked security problem, which is compromised user accounts and account takeover. And this is a problem that has pretty much skyrocketed in the last couple of years. And I think one reason because it's why it's so overlooked, it's because it's not necessarily a technical problem that can be solved like any other security issues, but it's more a problem with users and the behavior of the users on web applications. So at Castle, we've been working with this problem for a couple of years now, and we've been collecting a lot of data from a lot of different web applications. And in this presentation, I wanted to show you some trends and patterns in attacks that is pretty much going on constantly towards sites on the internet. And to kind of give you a visual idea of what I'm talking about, this is a map with real traffic from one of our customers. And let's see if it's playing. It's playing, yes. The blue dots represent legitimate traffic. And this is attacking traffic towards this site. And it kind of gives you an idea of the scale of this problem. And during this presentation, I will be doing a more deep dive into more of these types of attacks. And finally, I'll be giving some tips on how you can be better prepared to handle these kind of attacks. I think it's kind of fascinating and to see the scale and the ferociousness of these attacks. And I think you will be surprised as well. First of all, anyone knows what this is? So yes, it is actually a common way of authenticating online, where it's a shared secret between you and a receiver. And by giving it to the receiver, you prove your identity to some extent. We use them every day. They're everywhere, logging into our favorite services like Netflix, Facebook, whatnot. But I heard someone mentioning it here. Ironically, it is also actually one of the most common words used as passwords. So password is the one of the more common passwords. So first of all, I wanted to talk about some of the problems with passwords, because these problems are exactly what makes these attacks possible and why they're so successful. So the first problem is that people tend to pick common words. And obviously, since a password is something you need to remember, you're going to pick something that makes sense to you. So like the name of your cat or your partner, or something even simpler or worse like the word password. So surveys and data from breaches show that passwords like these actually make out a significant portion of passwords used. So in fact, 25 most common words make up more than 10% of the passwords used online. So just imagine that if you were to just randomly try to log into a user account on a random surveys using any of these passwords, the chances of you succeeding is actually pretty high. And this is exactly something that is taken advantage of by attackers. So it's important to pick a hard-to-guess password. The second problem is that passwords are reused across different sites by people. So even if you pick a hard-to-guess password, you still need to pick different ones on the different sites you're using. So having simple passwords was probably fine back in the days when you only had a handful of accounts. But now the average user has about 90 different accounts connected to an email. And this number has increased a lot of the recent years, and it's only going to get higher. Because even if we only use a handful of services on a daily basis, there's a lot of sites out there that makes us sign up with email and password because they want to use our email for marketing purposes or some other thing. So every time we sign up with one of these services, we store our credentials at that site. And so surveys show that most people tend to reuse their passwords, and on average, we tend to reuse 5 passwords. So again, not only do you have to pick a hard to guess password, but also a password that is unique per service. And that's a lot of work. It's a kind of a big burden that is put on us as users on the internet. So also there's no way you're gonna remember all of these sites that you have signed up for. And so every time, imagine if every time you sign up on the service, you're going to store your passwords there. And this kind of leads me to the next problem, because you put a lot of trust in the services that you sign up for. And the third problem is that passwords are leaked. And this is not necessarily the user's fault, but more related to traditional security problems with sites. So we see it in news pretty frequently. Pretty much every day there are new breaches happening. And every time this happens, new attacks on websites occur. There's a pretty cool site called breachlevelindex.com that keeps tab over how many data breaches they've seen since 2013. And as you can see in the screenshot here, we're now at 14.7 billion records breached and leaked. And surprisingly, there's like 6 million added every day. The a second cool site that I wanted to show you is the haveibeenpwned.com, and I'm sure many of you already know about it, but they actually allow you to go there and enter your email and see if it's been part of a breach. And they also collect a lot of breaches, and this graph just that kind of gives you a sense of the scale of the problem, and we're now at 8 billion plus records reported and stored at this site. And even if some sites don't store passwords in clear text or with weak hashes that are reversible, the attacker gets a lot of emails from these breaches and dumps. So a quick poll here. Anyone knows what a password manager is? Very good. I'm pleased. So anyone knows how they work, and does anyone know someone that is not using a password manager or some sort of scheme? All right. But so a password manager is a pretty simple concept. You use one master password to unlock passwords that are automatically generated for each site that you sign up for. So it's a way for you to become better at generating unique passwords per site that are random long strings that you can't remember. And there are plenty of good alternatives out there, both commercial and open source. So I encourage you to use one if you're not already doing that. But the problem is that they're not used by a lot of people, and using them can be a bit awkward. If you want to sign in on your TV with your Netflix account or something. And they also come with different set of problems, like you put all your eggs in one basket, and recovery can be tricky if you forget your master password. But overall, I think they do more good than harm. Okay, so now when we talked a bit about the problems with passwords, I want to talk about why these problems are useful for attackers. So these attacks typically come in 2 flavors, and the first one is called password spraying. And it's exploiting the fact that the first weakness that we talked about with passwords, and that people tend to pick common and simple words. So the attackers are using a list of emails together with the most common passwords, like the one we just saw, and they're trying it and testing them towards the site. The second flavor is called credential stuffing, and it exploits the fact that passwords are reused between sites, and that people don't tend to change password that often. So a quick overview of how it works is that the attacker has access to one or several lists of these breached credentials, and they are typically found on the dark web and combined into huge lists of credentials. And the thing is that these credentials are known to be good somewhere, on some site. So the next phase is that the attacker will try to validate these credentials by continuously logging in, trying to log in at the website. And they will load these credentials into tools and scripts and run these. They will also try to anonymize their traffic by blend into the normal traffic of the site by using proxies or botnets. And I'll talk a bit about that more later. So once the attacker has a confirmed list of credentials, they can sell this online. So the outcome of this whole procedure is that they had a huge list of credentials. Some of them could work. And by testing it to the site, they now have a list of working credentials that can be useful and that can be sold. And some of these accounts are, obviously still likely to work. So the first phase here is checking credentials. And once you have the list of leaked credentials, you need to check them. So to kind of give you an idea of how this works, I put together a very simple bash script that is essentially an account checking tool. So the basis of the tool is a list of credentials. In this example, it's a CSV file containing email and password. And the next phase for the attacker is to figure out how is the login request made on the particular target site. In this case, the login is made by making an HTTP post request to the /login endpoint and submitting the email and password as normal form values. When this request is sent, the server will respond with some response indicating that this login actually succeeded. In this case, the tool is checking for a HTTP status code of 200, indicating a successful response. This can vary a lot, but there's always something in the response that will tell you whether the login was successful or not. What's also common is that the attacker will try to mimic normal device information. So the user agent string is a string that typically is passed by all devices that connects to web services. And in this case, it's set to mimic the latest version of Firefox. In reality, this process is probably a lot more complicated, and that's why there are a lot of tools out there. So if you're curious, I recommend you to just Google for account checker tools. These tools are pretty much available to download, and you can just start using them. But they have a lot of neat features built into them that makes the barrier of entry really, really low. So pretty much anyone can run these. And you can also find on forums, you can find like pre-made configurations for different sites. So they have a couple of features. Obviously, they need to be able to determine if a login was failed or successful. But they can also control the timing of the requests. So essentially, you can control how fast you want to perform these login requests to not trip up any alarms at the site. You can use proxies. It's super easy to load lists of proxy IPs in there to kind of spread out the traffic. And another neat feature is that these tools can actually also solve CAPTCHAs. Now, CAPTCHAs are these annoying things that we are all exposed to, where probably Google will show us an image of something and ask us what is in it, and in return, we're allowed to log in. And the whole purpose of those tools is to detect whether the whole purpose of a CAPTCHA is to detect whether it's a human or a script or automated tool that is logging in. And if solving CAPTCHAs is part of the account checker features, this kind of defeats the purpose of CAPTCHAs. And personally, I think CAPTCHAs will go away in the future because they're super annoying and they're becoming less efficient against these type of attacks. So using proxies is one of the features of these tools. And the key to running a successful attack is to blend into the site's normal traffic and to distribute the attack as across many IPs as possible. So as you already know, probably an IP is something that every device has that connects to the internet. And normally when a site is having normal traffic, it's kind of reflecting that one user has one IP, roughly. Sometimes the IPs are shared, but obviously the attacker wants to mimic this by using as many IPs as possible. And an IP carries a lot of sensitive information, and sometimes it's down to street level location information. So the attackers need to hide their identity, so that's why they're using proxies. So proxies are just simple. They allows you to funnel traffic and hide your IP and location. So these IPs can come from different sources. A very popular one is to use data center proxies. And these are basically internet services designed for serving web applications like Amazon, DigitalOcean, OVH, a lot of different options out there. And they allow you to put your IPs in different locations to match the location of your anticipated user base of your web services. And for an attacker, the advantages of these is that they're fast, they're stable, they provide really good uptime, and they're fairly cheap. The downside is that they're less anonymous because you need to create an account at these services and sign up to start using the servers and create virtual servers at these places. But the attackers can use hacked accounts to log in to create spin up servers and run their tools. So there's always a way to get around this. The second source is to use residential proxies, and this is something that have become really popular the last couple of years. And it's essentially IPs that belong to normal home internet users. It's designed for personal use, and there's services out there where you can buy IPs from residential proxies, and it's a bit unclear where these IPs actually come from. Some of these services allow you to download a software onto your computer, and in exchange for your IP, you will get another proxy IP that you can use if you want to surf anonymously. But I've seen reports showing that a lot of these IPs actually come from malware on devices like home routers or printers. So it's kind of questionable where these IPs come from, but nevertheless, it's super useful for an attacker to use these because they're much less likely to get banned. And the third type of IP and proxies are botnets, and this is similar to the residential IPs because it typically consists of hacked devices that are connected to the internet. Devices containing malware, so they can be controlled by the attacker. So proxies are used to become anonymous, to obtain more IPs to spread out the traffic, to obtain localized IPs so you can pick the location where you want to run the attack from, and to obtain common IPs that are used by normal human beings. So let's have a look at some of these attacks. The first one I'm going to show you is a less sophisticated one. It's probably something that could have been run by the script I just showed you. So again, here we see the same map. This is traffic throughout the day. You will see the time of day fast forwarded up in the left corner. This traffic is mainly coming from a US-based site, and all of a sudden you see a red dot appearing in Europe, and then a second one. So in this particular case, they just ran a script from two different IPs. So it's pretty obvious. They were using two different data centers, so they probably just bought some cheap server, and started to run these scripts with the credentials. In total, they ran 900,000 different attempts over the course of 30 hours, so meaning that the list that they were using probably contained 900,000 different credentials. And in the end, they had 0.1 of this list was actually valid credentials that were still working. So they were able to validate the credentials. And just to give you a sense of the scale here, the blue bars represent the normal traffic for the sites, and it's typically pretty calm and easy, periodically varying. But during the attack, you can clearly see that something is going on. So it's pretty obvious that something is happening to the site. The second attack I want to show you is a bit more interesting. It's the same map as you saw in the beginning. And again, this is traffic from a US-based site. And in a while, you will see the whole world lighting up in a beautiful way. And I think it's really fascinating to see that something so evil can be so beautiful and spread out. Yeah, so to summarize that attack, they were actually using over 60,000 different IPs. So it's a pretty large-scale operation. And these IPs coming from 210 different countries. So they basically were able to spread out across every country in the world almost. The list that they had was 700,000 credentials long, and they run the attack over a course of 10 hours. And again, they had 0.1% valid credentials in that list. And this is probably a very good example of the botnet attack, because there's no way you can coordinate so many servers and you know, if you buy servers on data centers. So obviously there needs to be malware that is controlled by attackers so they can coordinate an attack of this scale. So to look at some details, these two graphs represent different properties. So the first one is fail logins per hour. It's pretty straightforward. Pretty low rate on the site normally, and then it spikes really heavily. But what's interesting is this second graph on the bottom, because normally one fail login corresponds to one IP, and during the course of the attack, this only increases from 1 or 1.5 to about 3 fail logins per IP per hour. So if you were only to look at that in isolation, you probably wouldn't notice a lot of difference. Third attack I want to show you is a localized attack. So in this scenario, the attacker, we see the same map, customer largely based in the United States, and in a while the attacker is running their script from multiple data center locations across the United States to try to spread their traffic and blend into what they think is the normal locations of the user base of that service. So in this attack, they were using significantly less IPs, only 1,000 roughly. But they were using multiple data centers. And in this case, it was actually not one of the big ones like Amazon. It was a combination of a lot smaller ones. Because the smaller data center providers and hosting providers typically has less security measures to prevent these kind of malicious behaviors running on their servers. The list that they had was 650,000 credentials long, and they run it over a course of 10 hours. But in this case, the list was only 0.02% valid credentials. So this means that their list was probably bad or old. But the fact is that this actually doesn't matter that much, because computing power is cheap and buying more IPs is cheap. So running an attack like this is actually pretty cheap. So, you know, they can just keep going. And again, same pattern here. You'll see that the blue bars represent normal traffic, and then all of a sudden you see a huge spike in number of login attempts occurring. But the interesting part is that in these graphs, you will see that it's pretty visible that that something is going on at site. But we've also seen attacks running on the course of several weeks on a much, much slower rate. So there's infinite variations how the attacker can run these, and they're only getting smarter. So I want to go through some ways that the attacker can improve their success rate when running these attacks. So the key goal is obviously for the attacker to find out which accounts in this list is working in as short time as possible, and hopefully go unnoticed. So the first thing they can do is to create fake accounts at the service. And these are essentially accounts that are controlled by the attacker. So at some point in time, they've signed up like a normal user, so they can log in with an email and password like any other user. And during the attack that they're running, they can use these accounts as probes to check out if the IPs that are using are getting blocked during the course of the attack. And another popular countermeasure is to not only measure fail logins per IP, but also keep tabs over ratios between successful and fail logins. And by continuously logging in with these fake accounts during the attack, the attacker can keep a better reputation from these IPs. So just to give you some examples, this was an attack we saw, and these patterns are all coming from the same attack. The green bars represent successful logins, and the red bars represent fail logins. It's really tiny text, but at the top you see 1 million requests per hour. So there's obviously a lot of logins going on here. And this is the bottom chart shows basically number of logins per account per hour. And in this particular attack, the attacker was using 6,000 fake accounts, performing logins up to 30,000 times during the course of the whole attack. And that means that they were logging in basically every 3 seconds with one of these accounts. And it's clearly not humans doing this because no one would log in that fast. The second way an attacker can improve their success rate is to use registration and password reset attacks. So remember I told you during the attack and when I showed you the maps of the attacks that the success rate was about 0.1%. So lately we've been seeing this success rate going up pretty significantly, sometimes up to 20 or 30%. And took us a while to figure out like what was actually going on here. But it turned out that the attacker was running registration and password reset attacks ahead of time before the actual attack to shorten their list. So they were basically taking advantage of UX features on the site for doing this. So this is a technique for reducing the amount of attempts needed in the final attack. So essentially, they're using the website as a tool to find out which accounts are existing in the database of that service. And the culprit is this little box. So you've all used one, I assume, but you would enter your email and you click a button, and if some sites will show you that this email exists in the database, or if it's not existing. And this is really, really valuable information for the attacker, because they can basically run their list of emails through this endpoint and cross off which accounts that are not existing in the list. So something that is really good for a UX standpoint to let the user know whether their email exists or not, or whether they should sign up or not, is actually really bad from a security perspective. Because the outcome of this operation is a greatly reduced list of credentials that the attacker needs to try in the final attack. So now when the attacker has its list of credentials that he have verified, what happens next? So the first phase here that we've been talking about is typically called the harvesting phase, where the attacker is harvesting valid accounts. And after this, the accounts are typically sold on the dark web. And the price per account that the attacker can charge typically varies a lot depending on what type of service it is. But for instance, fintech accounts or healthcare accounts, they contain really sensitive information. They're typically more expensive because they can be used in other types of identity fraud further down the line. And I've seen a lot of numbers out there, but everything from a couple of cents to tens and 20s and 30s of dollars per account. So the price can vary a lot. So then, up to a couple of months later, these accounts are tested by the buyer. And this is typically performed with a normal browser on a, sometimes hidden by using a proxy service. And then, in the end, the buyer of these accounts can execute the fraud that they had in mind. And this fraud obviously also varies a lot depending on the service, but they can do everything from logging in and changing bank accounts or changing email, shipping addresses, so they can ship goods to an anonymous PO box, and the possibilities here are endless, as you can imagine, if you have access to someone's account. So just to give you a sense of how the consequences of these attacks and how bad they are, just in 2018, the estimated cost of this was around $5 billion. And to give you some perspective, the Øresund bridge between Malmö and Copenhagen is about $4 billion. So it's one bridge a year in cost. This is made by a report by a company called Juniper Research, and it's a lot of money because it's not only about monetary loss, it's also the cost in terms of recovery procedures that needs to happen for the users, legal issues, and brand damage control when the breaches are published in the media. So this type of method of hacking has actually got up to become the #1 method. And it's simply because it's so easy to employ and it's super successful. Because it allows the attacker to essentially bypass most defenses that are already implemented by the site. And because they're so successful, the scale of them has increased a lot. And this is makes great success for the attacker. This report here that I'm referencing is actually a report by Verizon, the big telecom provider. And they release this report every year, and it's called Data Breach Investigations Report. And the name sounds really, really boring, but it's actually a pretty fun read, and it's pretty entertainingly written. So I actually recommend you to check it out. Most of it's pretty short and contains a lot of graphs over different types of attacks and stuff. So in this particular graph, you can see that the #1 hacking method is the use of stolen credentials, and it's much more popular than, for instance, something like SQL injection on the websites. All right, so now we've talked about how these attacks are performed. I wanted to go into a section where I can give some tips on how to defend your site and to make you more prepared for these types of attacks. So the first tip is to employ something like IP rules and blacklisting. It's basically the concept of if you see too many malicious attempts or too much malicious activity from an IP, it will be banned and added to some form of blacklist until some amount of time has passed. There's tons of options out there, open source, and there's a project called Fail to Ban that is doing exactly this. It's keeping track of some bad event until they've seen enough about these bad events, and then the IP will be blocked. Most web servers and reverse proxies out there actually have pre-made configurations for this, so like Nginx, Apache, and Microsoft IIS. There's also commercial offerings available on a lot of cloud providers out there. So Amazon and Cloudflare, they have something called Web Application Firewalls, or WAFs. And these tools essentially allow you to set up rules for malicious activity, and they also allow you to load lists of bad IPs. The downside of this is that the more sophisticated attackers, they tend to not reuse IPs between attacks, so these solutions can be a bit inefficient. But the pros are that these are super simple to implement, and they stop the obvious attacks. So for instance, the first attack that I showed you, if you remember, the 2 different IPs, that will typically be stopped by these kind of countermeasures. The cons here is that these are tedious to configure. It requires a lot of research and manual work to continuously update these rules. And you actually can risk locking out users and without you knowing that they're getting locked out. And especially now, these days, when, for instance, on mobile applications used on cellular networks, you have hundreds of devices sharing the same IP as opposed to normal home users. So tuning these rules is really hard and error prone. The second tip, I touched on this briefly before, but don't be a tool for the attacker. So basically, if you have registration forms and sign-up forms, password reset forms, remove any tells of showing that this user actually exists in your database. So instead of saying, hey, sorry, we couldn't find this email, say that if this email exists in our database, we will send you an email with the password reset recovery instructions. Same for email-based signups. You can use a similar message. You can also disallow the use of common passwords, like the ones we saw in the beginning. And there's resources to this for loading lists into your server and checking against this, and I will mention some of them later. You can also disallow disposable emails to prevent the attackers from using these fake accounts that can be used to increase the success rate. It depends on what type of service you are, but these are some of the things that you could do. Third tip is to actually use tools, and there's plenty of open source and libraries and lists and everything out there, and they're typically free and just simple and easy to use. So the first one is the leaked passwords database, the Have I Been Pwned site. They have APIs, so you can actually, during the sign-up process on your website, you can check whether a password has been part of a breach. And you can inform the user that they need to check, they need to use another password. List of disposable emails that you can load. It's basically a list of top-level domains belonging to disposable email services, and these are email services that allows you to sign up to get a temporary email address if you just want something to throw away later. List of IPs, both abusive IPs and data center IPs. Chances are that if traffic are coming from any of these IPs, that it's not with any good intent. Data center IPs is typically a sign of some form of scripted access, which could, depending on your service, be good or bad, but for most probably it will be bad. All these things are, open source, well maintained, so I encourage you to check them out and just start using them. Fourth tip is to inform the user when anything sensitive happens to their account. So a lot of best practices around this, but some tips is that notify the user whenever the password is updated on their account. Since the password is not updated that frequently normally, this is not something that you risk spamming the user with either. You can also let the user know if any sensitive information is updated in the account, such as address information, bank account information, or anything else that could be very sensitive. And finally, also when transactions happening, like if someone is moving money or executing some power in the account. Fifth tip is to check out this guide. It's actually a really, really awesome guide written by the Open Web Application Security Project. And not only does it contain information about this problem we've been talking about today, but a lot of good tidbits and nuggets to takeaways for other types of security problems as well. And they have both a wiki with a lot of stuff, but they have also this cheat sheet series website, which is really nice website, so check it out. So finally, to recap this, we have new breaches happening every day at a very alarming rate. Over 6 million breach records are added every day. Attacks are getting more and more sophisticated, everything from the simple attack that we saw until sophisticated distributed attacks using many IPs distributed across the world. And it's only a matter of time before this traffic is getting indistinguishable from normal traffic. Everyone here is a target. Websites, large and small, maybe in particular small sites because they have less defenses against these kind of attacks. And if you do have a web service, try to be thinking about ways to tackling this problem ahead of time, both from a technical point of view, but also how you can keep the user in the loop here and inform them when something happens to their account. Finally, be safe. I recommend you to use a password manager or at least some form of scheme to generate unique passwords per site. And I recommend you to always use two-step verification, because by having unique passwords, we kind of help fighting this problem. And until the day when passwords are replaced as an authentication mechanisms, which I really hope is happening soon. Thank you very much.